We are starting a new chapter. This is called The Nature of Logic. And in section 3.1, we are looking at deductive reasoning, which we talked a little bit about this in chapter 1. So let's dive in and see what this section is going to be all about. We've got quite a few definitions and terminology to cover in this section. So we're going to start out by talking about statements, and a statement is really kind of what you would think a statement would be. It's a declarative sentence that is either true or false, but not both true and false. So that's kind of a simple way of putting it, but also a little confusing. So let's get some examples. So this is a mathematical statement, which says 4 times 0.25 is equal to 1.00, or you can say 4 quarters equals $1. So that is a statement. It is true. It cannot be true and false at the same time. So that is a true mathematical statement. All right. Who is the president of NOBTS? That is not a declarative sentence. It's a question. And so this is not a statement. Okay. I am a preacher's wife. That is a statement. It can be verified as a true statement. You can actually find out if it is true or false, and it is true. And so if you can determine the validity of it and everybody can agree, then it is a statement. So that one is a statement. I am the best math teacher ever. Well, I would love to say that this is a statement, but it really isn't, because it's a matter of opinion, and it could be both true and false, which is hard for me to accept, but it's not a statement. So that is kind of just helping you figure out what is the difference between statements and not statements. So if it's a matter of opinion and you can't verify it as definitely true or false, then it is not a statement. You've got some easy questions on your homework that you're going to have to pick out, like which are statements and which are not statements. So that's just a little exercise to help you with that one on your homework. The next thing we're going to do is we're going to practice negating statements. And where this comes tricky is whenever you have some different qualifying terms like the word all. So here I have all NOBTS students take Bible classes. And what I want to do is I want to negate the statement. So I want to negate it. And so the way that you do that is that you use this specific terminology that some NOBTS students do not take Bible classes. So if I wanted to negate any statement that has the qualifying word all in it, then you can use the words some, the combination of some, do not, okay? So some do not. So there are special combinations of these different qualifying words, is how I call them. And so I'm going to give you this chart, which is actually found in your textbook. So all, and then the negate of that is some do not. If we said some NOBTS students take Bible classes, the negate of that would be no NOBTS students take Bible classes. Okay. If we were to start the sentence out as some NOBTS students take, some NOBTS students do not take Bible classes, and you wanted to negate it, then you would say all NOBTS students take Bible classes. So it's just the opposite of the example that we have at the top of the page. And then lastly is if you started out and you said no NOBTS students take Bible classes, then to negate that, you would say some NOBTS students take Bible classes. Okay, so this chart will come in handy for some of your homework problems. And these are just different statements and their negations. Now, if I were to give you some preachers do not go to seminary, okay, how would you negate that? So you can pause the video for a second, and then I want you to use that chart and figure out how would you negate that. Okay, to negate that, we would come to our chart, and we would realize that some preachers do not. So I'm seeing that my original statement uses this some and not. Okay, so I'm going to come over here and it says some and not. So the negate of that is all. So I need to rewrite this using the word all. So all preachers go to seminary is the negate of this. So all preachers go to seminary. All right. Hopefully you got that right. And I think you've got a couple of these on your homework as well. We're going to continue talking more about terminology. And in math, we like to shorten things and give everything a letter. If you haven't noticed, we like to give letters. Like statements, letters, everything gets a letter. So I know you think that math is all about numbers, but in this math class, everything's about letters. So, okay, so here is the statement. These are two true statements about me. So I'm going to let P equal to the statement, I am a student at NOBTS. And I'm going to let the letter Q equal the statement, I am half Korean, which I am. My mother's Korean. My father was American. And so, so those are two statements. Now, so if I wanted to write that I am not a student at NOBTS, then I would write this little squiggly mark here, which is a tilde P, or squiggly P. That is representative of this statement. I am not a student. So can you imagine what I am not half Korean would be? Yep, not far-fetched. It would be that tilde Q or squiggly Q. Okay, so that's what that would look like. All right, then whenever we write this little carrot top looking accent up, that is shorthand for the word and. And then if we turn it and go downward like this, that is shorthand for the word or. Okay, so this is all that you need to know for this particular slide, because now what we're going to do is we are going to take a sentence. So we're going to take this sentence, I am a student at NOBTS and I am half Korean. And I want to write it in this shorthand mathematical way. So using all of these letters, I want to write this sentence using their mathematical representations. So I am a student at NOBTS. I'm going to come up here, and I am a student at NOBTS is P. Okay, so I can write in P, and then and is this little arrow up, the little carrot top up. I am half Korean, which is Q. So this whole sentence right here in English, in mathematical terms, is just this little bitty 3 little characters. So it's a shorthand way of writing it. In math, we use letters to represent everything. And so that's just a shorthand way of doing that. Okay, so now I want you to pause the video and I want you to practice. I am a student at NOBTS, or I am not half Korean. So pause the video and I want you to think about, what do you think that would look like? Okay, so let's see if you got it right. This is, I am a student at NOBTS, which is P, or is the V, or the opening up, okay? And then I am not half Korean is the little tilde Q. And so that would be how you would write that in the mathematical shorthand, okay? So this is a logic statement. These are called logic statements. And that would be how we would write that logic statement. Okay, now we can also go the other way. So let's say that I gave you this statement. I gave you this not P and Q. Okay, so that's how I would write that, how I would say this. Not P and Q. Okay, so the tilde P means not P. Arrow up means and. Q. So not P and Q. Now, what does not P mean? Not P means I am not a student at NOBTS. And what does Q mean? I am half Korean. So if you were to be given this on your homework and asked to write out the sentence that it represents, then that's what you would do. You would say, I am not a student at NOBTS, and I am half Korean. Okay, so on your homework, you're going to have several examples where you have to go backwards and forwards. So you're going to have to go where they're going to give you this part and ask you to write out the logic statement. And then they're going to give you the logic statement and ask you to write the statement out. Okay, so you're going to have to go back and forth. They're going to give you these things right here. They're going to say, okay, what is P and what is Q? And then they will give you the logic statements and then have you actually go back and forth. All right, so hopefully that will help you out. We're going to look at another set of P's and Q's. P's and Q's are going to be used over and over in this particular video. So this is going to be another set of P's and Q's. I am a preacher's wife is P, and Q, I am a teacher. Both of these are true statements about me. So I'm using myself in this video over and over again. Now, what I want to do is I want to look at this particular statement. So I put this statement, I am a preacher's wife and I'm a teacher. Okay, so I joined it together just like I learned in the last slide by using this correct terminology here. Now, when you use the word and, this is called a conjunction. This is another term for you to know. A conjunction is a compound statement, meaning that we combined two statements together, and it uses the word and. So what we want to know is, when is a conjunction true? Okay, so I started out with two true statements. Okay, these are true statements, and I want to know when you combine them, when are they true? Okay, so and what we're going to do is we're going to look at what is called a truth table. And the truth table is going to help us kind of sort things out to know when compound statements and conjunctions are true. Okay, so let's take a look at this conjunction here. So I'm a preacher's wife and I am a teacher. I have my P and Q. This is what a truth table kind of looks like. This one is a little more detailed, so that I'm going to write out my sentences, statements over here. That's going to help us to kind of go through this. So the first statement is going to be, I am a preacher's wife and I am a teacher. So that is this particular statement right here. So P is true, Q is true. Okay, and these are true statements. All right, so I am a preacher's wife and I am a teacher. Those are both true. So when you combine both of those, P and Q, when I say that about myself, they're both true. So that compound statement conjunction is true. Now, what happens whenever I say I am a preacher's wife and I am not a teacher? Okay, so that's basically saying that P is true and Q is false. Okay, so now when you combine P and Q together, let's see, is that a true statement? Okay, I'm a preacher's wife and I am not a teacher. So let's think about that. Well, for me, that is not a true statement because I am a teacher, right? So I am a preacher's wife and I am a teacher. So this is not a true statement. So this would actually be a false statement. Okay. Now let's see whenever we can say this a different way. I am not a preacher's wife and I am a teacher. All right, so that means that this time I'm saying that P is false and Q is true. Okay, same as in number 2, we're now saying I'm not a preacher's wife, but I am a preacher's wife. All right, so when I put these two things together and I say this one is false and this one is true, then this is going to be a false statement as well, right? So that is false. Now, what happens when you say, the only other combination with this is when we say, I'm not a preacher's wife and I'm not a teacher. Okay, that is two false statements, false and false, and you get a false statement at the end because, well, I'm both of those things. Okay, so this is all of the different combinations that you can do with P and Q. You can have true, 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 false, false, true, and false, false. And so these are the different outcomes that you come. Now, the most important one here is that whenever you combine these with the word and, the only time that it is true is when both of them are true. Okay, so that is something that you're going to want to remember, is that when you have the combining word and in a conjunction, the only time that it is true is when both P and Q are true. Okay, all the rest of the time it's false. All right, so see if you can remember that. Now we're going to look at the same exact statement except that we changed and to or. Okay, and we're going to see how it changes the outcome. When we change the word to or, this is called a disjunction. It's a compound statement using the word or. And so we're going to do the same thing. We're going to make a truth table using this word or. And when is a disjunction true? Okay, so let's see if we get something that's different in this case by just switching that one word to or. So I've gone ahead and I've kind of pre-filled in most of this table because it's the same exact statements and the same exact P's and Q's that could have been. All right, so these are the same options that it could have been with the same different sentences, okay? Let's think about number 1. I am a preacher's wife, or I'm a teacher. Okay, so both of those are true. Therefore, P or Q are true. Okay, so that's true. Now, I am a preacher's wife, or I am not a teacher. Let's think about that. Well, I am a preacher's wife. That's true. Or I'm not a teacher. Well, because of that word says or, well, this first part is true. I'm not a teacher is false, but this said or. So since it said or, this first part was true. So one of them is true. So that means at least one of them is true. And because it says or, then this combination compound statement is true. Okay? So I'm going to say that that's true. The same thing is going to go here. I'm not a preacher's wife, or I am a teacher. So the second part of this is true for me. The first part was false, but the second part is true. Since the second part is true, that means that this statement is true. So we can put a true there. Now, on this last one, I am not a preacher's wife, or I am not a teacher. Now this is two false things. So false or false. Well, those are both false. So that whole statement is false. So finally we get a false statement. So now I want you to see how different this is. Just by changing the word to or, it is true all the time except for when you have both false statements. Okay, so this is true all the time except whenever you have P and Q are both false. Then you have a false statement. All right, so this is going to be very important for you to remember as well. Now we're going to see, what are we going to do with these truth tables, and why did we go over all of this? Okay, so let's talk about why we did this. So we're going to look at some examples from your homework, because I think that that is the easiest way to kind of help you understand how to use truth tables. So the easiest way for me is that I use, what I do is I take a small version of the truth tables and I write them down on a piece of paper. So I put them on the slide here for you. I have my conjunction, my and truth table. I call it the and because conjunction and disjunction is hard for me to say. It takes too long. So I call it my and chart and my or chart. That's what I call them. So if you can say if you like to say conjunction and disjunction, you go right ahead. This is my and chart. This is my or chart. So they are going to be your very, very good friends. You need to be able to write these charts and be able to replicate them. Okay, so just know that you need to be able to write them over again. They're easy. You'll learn how to write them pretty quickly. All right, this is a question where it says, assume that P is true and Q is false. Okay, that's what that means. P is T, Q is F. That means P is true, Q is false. Under these assumptions, are the following statements true or false? Let's look at the first one. All right, the first one is P and Q. Okay, P and Q. Now your first step in this is let's put in trues and falses for P's and Q's. So P up here in the problem, P is true, Q is false. So out to the side here, I'm going to substitute in true and false for P and Q. So this is really asking me, what does it mean when you have a true and false. Okay, so I am going to go over to my AND table, and I'm going to find the combination of true and false. So this is the red one is my AND table. True and false is false. Okay, so did you see that? I went to my AND table. True and false is false. So the answer to this is false. Okay, so that's how we use our truth table. Let's look at another one. P and not Q. Okay, oh, sorry, P or not Q. P or not Q. All right, so I'm going to substitute my truths and falses. So I'm going to go back up here. P is true, Q is false. So P is true. If Q is false, then not Q would be true. Okay, so this would actually be true or true. True or true, because this says not Q. Not Q would be the opposite of this, which would be true. False, opposite is true. Okay, so I'm going to go to my OR chart. I'm going to look for true or true is equal to true. All right, so that's not too bad. Okay, you with me? Everybody taking deep breaths? Okay, now I hate to tell you, but these just get uglier. All right, they get uglier. Okay, now we're going to get a little uglier, and we are going to have P, Q, and R. Okay, you ready for this? So we have 3, and notice you have some parentheses as well. So this is going to put the order of operations into play, and that's going to be very important. So in this particular example, we're going to have to actually do the order of operations and do what's in parentheses first. So what I'm going to do first is we're going to do the same thing we did last time, which is substitute our trues and falses into the problem first. So substitute all of your trues and false from what they have given you. So P is true, Q is false, R is false. So we're going to substitute those into from the problem just like you see it. So true and false or false. Now what I'm going to do is I'm going to do false or false. So I'm going to go to my OR chart. False or false is false. So I'm going to do that parentheses first. So that left me, so this false right here came from false or false. This true and came from right here. Okay. So now I'm going to go to my AND chart, and I'm going to say true and false is equal to false. So the answer to that particular problem is false. So that wasn't too bad, right? Sure, Miss Baker, that's not too bad. Okay, now it's going to get really, really ugly. I know. If you need a bathroom break, this would probably be a good time. Pause the video, go get you some sweet tea, something like that. You know. All right. Now, this is just full on ugly. So we have lots of knots. We have lots of parentheses going on. And so, yeah, it's just ugly. But we're going to tackle it and we're going to get through it. All right, so the first thing we're going to do is substitute in all of my trues and falses. We're doing the same steps over and over again, okay? So go up to your problem, substitute P is true, Q is false, R is false. So I'm going to do that direct substitution. All right, so everything looks exactly like it did. Now, what I did here is I'm going to first go ahead and do not false is true. all right? Not false is true. And this not came down here. So this not right here came here, all right? So I did this first set of parentheses. So not false is true. And then this not came down here. Everything else stayed exactly the same. Now I'm going to go ahead, I know there's not parentheses here, but I'm going to go ahead and just simplify this and say not true is false. That's going to go ahead and finish that up. All right. Now I'm ready to tackle the second set of parentheses. Okay, the second set of parentheses. So I'm going to come over here and I'm going to say true and false. So go to your and chart. True and false is false. Okay, true and false is false. So this false came from right here. I brought my not down right here. Everything else stays the same. All right. Now, what is not false? Not false is true. So we're going to now have false or true. False or true. So we're going to go to our or chart. False or true is true. Ding, ding, ding. Okay. Yay, we finished the ugly problem, the whole ugly thing simplified down to the answer, which is true. All right, be very proud of yourself. That was a really ugly problem, and you made it through to the end. Okay. All right, now we have just a couple more slides to go, and this section will be behind you. I wanted to finish out this section with a couple more examples from your homework. What you have here, it says translate the statement into symbols. And so what they're going to do is they're going to give you two different statements, like T is equal to, so I'm giving you a couple of statements. T is going to be the deacons will meet tomorrow. M is going to be the choir will practice tonight. So now they're going to give you this statement. So this statement, the choir will not practice tonight and the deacons will meet tomorrow. So the choir will not practice tonight and the deacons will meet tomorrow. So let's kind of take this bit by bit. So the first one is the choir will not practice tonight. So let's go back up here. What we have is that M is the choir will practice tonight. So we have the choir will not practice tonight. So what would we do with this M? So instead of M, we have not. So it would be not M. Okay, so I'm going to go down here and I'm going to put not M. All right, now we have the conjunction is and, so we just need to go ahead and put the and symbol. And then the second one is the deacons will meet tomorrow. And so that is the statement exactly like it's written. So that is just T. So the answer to this question, where we translate this statement into symbols, is that we have not M and T. Okay, so that's not too bad at all. It seems like a very daunting task, but it turns out to be not so bad. Okay. Just like everything else, we can't leave well enough alone without making things a little bit uglier. So we are going to throw 3 statements in there and try to confuse you a little bit more, and then we're going to call it a day. All right, so T, the building style will match the church grounds. M, the building style will match the community. R, the building style will match the current trends. Okay, so here is the statement. The building style will match the church grounds and will not match the community or current trends. And they want you to put it into symbols. Okay, so let's kind of break this down. So the first one is the building style will match the church grounds. So that is directly T, right? So the building style will match the church grounds. The building style will match the church grounds. Okay, good. We got lucky on that. That's just T. And then we have the joining word and. So we just have the and symbol. All right, then we have will not match. Okay, so we know we're going to have a not, so I'm going to have my not symbol. But then it says the community or will not match the community or current trends. So we have a combination here of the community or current trends. So this is a little confusing because we are combining the community or current trends. So now we have to figure out how we're going to do that. And the way you're going to do that is actually by using parentheses. So it's not going to match it. And the way that that's going to look, it's not going to match the community or, so I had to use the or symbol, current trends. So I want you to take a look at that and see if that makes sense to you. So this is M, which says it's matching the community, or R, which is current trends, and then I have my not. Okay, so it is going to match the church grounds, and it is not going to match the community or current trends. So it's kind of cool that you can translate it into symbols like this. So there you have section 3.1, logic statements, and that is the beginning of our logic, nature of logic, and there you have it. So I know you have all been greatly enlightened, and I'm sure you all have wonderful questions of when in the world am I ever going to use this in ministry. And I'm going to think about that for a little while. Okay, thank you so much for all of your hard work, and you just keep up the good work.